When we think about displacement or velocity or speed, it's handy to know a starting point and where we're going. If we think about this, this is how we have normally discussed lines in the past. Your most basic line, y equals mx plus c, well, we've got c being a point that we know, a fixed point. Normally we call that point the y-intercept. And then our slope gives us our direction. It tells us which way to go from this fixed point. Well, we can do the same things using vectors. If I think about a known point, so let's say that I have this point A that's a known point, coordinates xa, ya, za. And then I have some sort of direction I'm heading. I'm going to call this direction vector B. So that means any new point on the line I can find by starting with A and then going in any direction, going in the B direction. So I could go this way, or I could go in the negative B direction to define any point on this line. Let me put in the line underneath here. Okay, so if I go through this point with my direction B, I can hit any random point on the line. So I'm going to call this R, some random point on the line. It has coordinates x, y, z. So to get to this point, I would start at the origin, and I would make OA. So I could call that vector A, and then I would add multiples of B to get my resulting vector, the new point on the line. So I could say that R is equal to A plus some multiple of my vector B. And that could be positive or negative because points could end up over here. So if I look in my formula booklet, the only thing that's different from this is that our formula booklet uses lambda instead of k. And remember, bold letters mean vectors. So sum xyz is equal to a fixed point plus multiples of direction. So let's put this in here. So random point equals fixed point plus multiple of direction. All right, let's look at an example to try this in practice. So we've got the points A is at 3, 4, B is at 5, 5. So my direction vector is going to be AB or BA, either way. To go from A to B, I would go to the right 2 and up 1. So I could say that any random point on the line is equal to my point A or B. Either one of these is a fixed point on the line, plus multiples of 2, 1. So if lambda is 1, I would get point B. Similarly, I could have said that it's the point 5, 5 plus multiples of 2, 1. So now if lambda is negative 1, I would get point A. I could have also used my direction as negative 2, negative 1 if I would have said my direction was BA.